Now we're going to do probably the most important part of this chapter. We're going to look at solving exponential equations using logarithms. In order to do this, we're going to do three basic steps. The first step is we're going to isolate the exponential on one side of the equation. Step 2, we're going to take the logarithm of both sides of the equation. And step 3, we're going to solve for the variable. Now, some textbooks will actually interchange step 1 and step 2. They'll actually start by taking the logarithm of both sides. I find it's much easier to first do our best to get the exponential all by itself on one side of the equation before we take the logarithm of both sides. Let's start off by taking a look at a rather simple equation to solve. Let's solve the following for x. 10 raised to the quantity 3x equals 72.45. So if we follow our three steps, first thing we should notice is the exponential piece is already isolated. 10 to the 3x is on one side of the equation all by itself. So now we can take a look at step 2. We're now going to take the logarithm of both sides. Since this is 10 raised to the, I'm going to take the log, the common log of both sides. So I'll take the log of 10 to the 3x equals the log of 72.45. Now, from our previous properties, we realized that log evaluated at 10 to the 3x is actually an expression that involves inverses. And so the log and the 10 will cancel out and just leave us with 3x. So we end up with 3x equals the log of 72.45. Now, all we do is use what you might think of as regular algebra and solve for x by dividing by 3. So if I do that, I get x equals the log of 72.45, all divided by 3. Notice, by the way, it's not the 72.45 that's divided by 3, it's the entire logarithm expression, log 72.45. You might want to check to make sure that you can get the approximate value of 0.62001 on your calculator before moving forward.